Hi, how are you?
Hi.
I hope you're all fine. Welcome to PyCon. Let me introduce myself before I begin. My name is Galuh. I'm currently a university student right now. I'm majoring in computer science in University of Indonesia. In the past few years, I've been working on some freelance web development projects for e-commerce and also companies. And in the past year, I found interest in data science, so I worked as a data science intern at Midtrans for almost a year. And now I'm focusing on working on my undergraduate thesis right now. So yeah. Right, so today I'll be talking about building a data-driven web app with Flask. So, the background. Well, first point is that I found lots of cool codes and blog tools, usually in the form of Medium posts. Maybe you've all read some, or in GitHub repository, or in a Jupyter notebook. But the problem is sometimes there's no way I can try them all unless I really run the code myself. So I really have to run the code. Sometimes, of course, it's a good way to learn how to build something, but sometimes you just want to see what it's all about without having to go through all the hassle. And I think the idea is to make whatever you're working on to be as accessible as possible to as many people, so that it will be able to also encourage other people, no matter how their technical level is, to actually build something, the same thing as you do, or maybe improve whatever it is that you're working on. I've also found instances where I need to create a prototype or a minimum viable product that non-technical users can use. So, of course, when it comes to non-technical users, saying that just code or run Jupyter Notebook is not the answer. And in some cases as well, sometimes non-technical users want to use a prototype that is as close as possible to the real thing. So maybe it's not perfectly the same, but at least like the UI is there, or like the UX or the flow is kind of similar, so that they can make a decision on it. Alright, so this is what we're talking about today, how we can turn something like this. Maybe if you've been building machine learning models, you do this on Jupyter Notebook a lot, or maybe on your Python script files, to something that looks like this, that everyone can understand. Okay, so before I get into the how, let's talk about why Python. Well, first, Python has lots of powerful data analysis libraries, pandas, NumPy, scikit-learn, and maybe if you've seen the Kaggle survey results, Python is the most widely used tool for data scientists. So it's no surprise that lots of data scientists use Python. And at the same time, Python is also good at web development frameworks. We've heard of Flask, Django, and various others, perhaps we discussed in the keynote previously. So we know that we can actually build something that combines data science and web development with just one language, which is great because it means that you don't need to learn multiple languages to actually come up with something, come up with a product. And it actually has a great community support because it's one of the most widely used languages in the world. So this means that you can save lots of time and you can focus more on getting the insight from your data, that's one thing, and also putting it out there for everyone. So when we talk about web development in Python, usually the question that I also get asked a lot is, should we use Flask or should we use Django? So, of course, the answer is dependent on what you want to build. But what I like about Flask personally is because it's very simple and it's flexible. You can actually get a Flask app running just from these few lines, just about 7-8 lines. You can get an app running. You can access the local host in the port that you select. You run this, and then you will get index.html that you have previously built. So it's very, very simple. But remember, it's always a good idea to assess what your application needs. For example, if somehow your data science application needs to have lots of creative, or if you believe maybe Django is better. But Flask is simple enough that you can learn it in no time to come up with something. And I've also linked some great intro tutorials to Flask. Right. So feel free to follow along. This is the demo that I put up. And this is the code, the GitHub repository containing all the codes and user notebooks that I use. So what I'll be showing you about today is actually an application that I've built for a paper that I submitted with my friends and my lecturer to a conference previously. So basically what we do is that we try to estimate the collective funding amount of social project campaigns from a crowdfunding platform. So let's say that you can link to a website, for example, this campaign. You probably know www.com, it's a crowdfunding website. Given the link to the campaign, we can see probably how much that the fundraisers will actually get, given like the story, the length of the story or the number of images, they all correlate. But we won't be getting into the methodology right now. I think the paper will be up in Article 84 soon, so if you want to read it. So today we'll be focusing more on the web development side of things. And so the application itself is more like a simplification, so probably the result won't be exactly the same with the one in the paper. But at least you all get the idea. Right, so let's get started. So before actually creating an application, I think it's always a good idea to start thinking about what you want to build instead of just diving right into it. So I think one of the tips that I use is that think from the perspective of users, what do they want to see? Because remember, we have to make it as accessible to as many people as possible. So thinking about the users is very important. So for example, in my case, I just want the users are the fundraisers of the campaign. I want them to just fill out the URL to the campaign, and then they'll get something like this. This is the collected amount so far. This is what's going to be predicted. We predict that it's not going to get funded, not going to fulfill the target amount. And then we also have several statistics, for example, so they don't have to really count one by one manually, like how many words that I have. We've all done it for them. We also get some data from Facebook. These are we get from Facebook Graph API, which shows that the number of shares that are contained in a post that contains this particular link. And we also show some like tips about how they can share the campaign link like this. For example, we see that their number of Facebook shares is 69, while usually campaigns that have collected this actually have around 700 Facebook shares, so maybe they can do that. Alright, so I already have the idea about what I want the users to see, so we can start talking about where does the data come from. We know that in my case, the data comes from the user, which is the campaign link, but then we also need to get some data from external sources, such as the website itself, and also Facebook. And that's the external data. It might be different for every application. Maybe your application will, maybe you already have the data that you have used. For example, you already have downloaded a data set, or maybe you have to put it in a database. That really depends on the application. So after we already know like where we get all the data, we can start talking about how we can accomplish the calculation. What are we going to do? In this case, I want to predict. So it's going to be done using the regression model that I've built. And then the output, we know that, okay, I want to display the results of our calculation in the previous step and also other statistics. So I think thinking this way will make it easier for you to actually break down what you have to do in terms of building your application. Okay, so here I'll be showing you the structure of the app that I have. So this is going to be a very example-driven talk. For example, I have in Flask, I already have the resource folder. So this is basically where I'm going to put everything. The model, which I will talk about later, and sometimes the difference is when we are building a data-driven web app, we need a lot of files, such as keeping the stopwords if you're doing class processing, or you have to keep the weight of TF-IDF and all that stuff. You can actually just keep it here, and then it will be easily accessible in your web application. And in Flask, we have the static folder is basically where the style sheet, CS, and images go, and then the templates. This is where the HTML templates go. We'll talk about this later also. And actually, the organization is really up to you. But what I like is that I separate everything to 3 different modules depending on my need. For example, I have one module specifically for getting the data, and then I have another module that concerns about doing the prediction, and I also have another module for displaying the graph that I want to show to the users. Okay. So how does we have really separate components there? We can combine it together with roots. So this is what's great about Flask is that it has a decorated full root, which basically binds the URL address to whatever function that you have. I think if you've used Python a lot, this is very intuitive because we deal with functions a lot. And if you want to bind a URL with a function, you just use the decorator. So for example, if I go to an address slash which is root or index, it will return whatever is returned with the function here. So for example, it will return the index of HTML file. And it's as simple as that. And in a more complex case, for example, sometimes we want to display some values, we can just pass some parameters here. So we render a template, which is called details HTML, which is located in the folder called templates. And then we display whatever we have calculated, whatever we have done in this space, we just pass them so that it will be able to be displayed in the HTML. So it's just as simple as that. I think once you get the grasp of this, you start to see the idea. The most concerning part is like this one, like we have to do a lot of things here. So we have to get the campaign link first from the user, then we have to collect the data, then we have to do the prediction, then we have to display the graph, results, plots, etc. And once we get all of these values here, we can just pass them here, and we will be conveniently able to display it in our web application. Okay, so for example, first one is that we want to get user input. Now this part is mostly HTML. We can use, it really depends. You may use a field or you may use a drop down. In this case, I only use one field. And what I want to do here is that I need to send whatever data that the user inputs to here, right? So that we'll be able to use the campaign link that we get to further calculation. Now we can just do it with HTML. We send it using the form action. We send it to the page called details, which is details is this one. So we use the method get. You can use get or post. It's up to you. And then basically we will already get it. How can we get the link? So Flask has a module called request. And by calling request.args, we will get the value that is passed in the query string here. And how can we call it? We can, since request.args will return a multi-dictionary, we can use the key. So I want to get campaign, and the key is located in here, the name. So the name that you put in the HTML is going to be the key of the multi-dictionary that is returned by request. So that's it. We've already done the first part. Now, so we already get the first part here. We know the link, so we know where can we get all of these data since we already have the link. What I did was that I had to do web scraping using Beautiful Soup 4, and I also had to collect the data from Facebook Graph API. So what it is that I just called the function that I created in the module that I set for the data.py. So I'll show you the code. So yeah, this is a lot of code because I did web scraping. So because the website itself doesn't provide an API that I can use. For example, I had to get the number of images, so I use Beautiful Soup to find that, so that I'll be able to say, okay, the number of images that is contained is 52, for example. And well, that's pretty straightforward, but I think not all features in machine learning are this straightforward. Sometimes we have to use a lot of feature engineering, which you can also do. For example, in my case, I also have a feature called text specificity, which is done using TF-IDF, calculating the TF-IDF. So of course, it's not that straightforward because I have to create a matrix, etc., and I do all of these here. So by the end of the function, I already have a value that I can use for prediction. So one thing to keep in mind is that we have to keep in mind the type of the data that we get, because we get a lot of data from various sources, such as Facebook and lots of unstructured data. So sometimes you may get the type of data that you don't want. Well, for example, we can think that if you want to predict something, of course, for example, for regression, of course, we cannot put a string in there. So you have to be careful because, especially when you do lots of web scraping, sometimes it returns a string, and you don't want that, so you have to convert everything first before actually using it for prediction. So now we get the data here. We get a dictionary. Now it's easy to use. We can just call data and then use the key with the statistic that we want. For example, data is org, etc. Now, for the prediction part, of course, you can use lots of different libraries that is available. In my case, I use scikit-learn, but depending on your app and necessities, you may use libsvm, gensim, TensorFlow. So yeah, it really depends. Now, if you have built a machine learning model, I guess a lot of you use Jupyter Notebook, and sometimes you just usually end like, where is it? Sometimes you build a model, you see the RMSE or the metric, and then that's it. I mean, like, it just ends up like, okay, the accuracy is 59%, or the RMSE is blah, 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 but then how can we actually put it into a web application that people can see and actually use? So the naive way is that, of course, perhaps you can just copy all of this into your prediction script. But then the problem is you will have to train the data every time you call the function, which is something that we definitely do not want, because training some data, especially for some algorithms, can take a long time. So one way to solve that problem is that we can just save our model, so we can call it whenever we want to use it. Now, there are a few approaches that you can use to save your model. A common way to use it is that we use pickle. Pickle is a pickle. So it's deserializing the object here. For example, we have an object. We have a regressor Python object here. Now, how we want to save it by deserializing it into a stream of bytes. We can use that pickle or joblib. So it really depends on what you need. Joblib is already optimized for NumPy. So if you're using scikit-learn, it's probably preferable if you use joblib. But in other cases, you may use other approaches. So in this example, we are going to use joblib. Let's say that you have built a model and you've determined, oh, okay, this random forest model is the best, and I want to use this. Now, what you need to do is that you just write a file name where you want to save it, and then you call joblib.dump, and then here's the class, and where you want to save it. So the joblib itself is already available in scikit. Yeah, it's already, you just need to import it. Now, if we want to use it in our application, then we just need to load it. It's as simple as that, and then you'll be able to use it the way you use it in a Python notebook. So if you want to predict, you can just call the loaded model and predict the input. that you have that you have gotten from the previous part, which is the data. So you can just use all of this, turn it into a pandas data frame, and load it into the model. So, however, there is a few things that you need to remember when using Joblib. You really need to keep track about the library versions that you use when you create a model, and also the versions that you're using when you load the model. Because if it's different, then you might come up with some problems. So there are a few approaches. So if you think that that's not going to be a problem, then you can use this. But if you are worried about that, you may find another approach. Okay. So, and I've also put a link about the talk that talks about other approaches. All right. So now let's talk about data visualization. Of course, many libraries are available. In this case, I use Matplotlib and Seaborn. Maybe usually you already have created data visualization here in a Jupyter notebook, and it usually just ends up here like, okay, plot that show, this is it. But how can we actually generate a plot that is different for every user input? So to do this, here is it. So for example, I want to show the graph of the average Facebook shares. This is the usual code that I use for building the graph. You can just copy paste it, for example, from your Jupyter notebook. Now the different part is going to be, okay, usually we'll just end it like plot.show here, right? Plot.show, but since we cannot do that because we want it to be dynamic. Now, one way to do this is that we can save the plot using string IO. So we are basically, what we're going to do, we are going to save the plot as a URL. Now, let's see. Now, in this case, when we click view image, it's going to be a long, very, very long string of URL. This is actually the entire image that you're saving. So using string IO, you can use, you can save the image that you've generated into string, and then you encode it to base64 so that it's safe to be passed as a URL. And then, yeah, we get the value. So this is like the part where it contains a really, really long string, and then we encode it to base64, and then we just pass it and return it, like you would with any other kind of data. So, right. Now, so let's recap what we have so far. So far, we already have all the data that we need to display to the user. We got this from web scraping, and then we got this from Facebook. And since we already get the prediction, we can also just, it really depends on what you want to do. You can just append or insert this to the dictionary that you want to use. Okay, so for example, I already have the prediction. Let's create a dictionary called prediction, which is contained with the prediction that I have just made. And you may want to modify some things. For example, you want to create an additional variable called isFunded, which means that if the data prediction is less than the donation target, then we set this to false or true so that we can use it in the HTML. And we just need to pass everything here, and it will be rendered in details.html. So here, Facebook shares, we also have the graph. This is like the URL to the plot that we have built. Now, the next question is how we can use it to display to the user. Let's say that we already have all this data, all this dictionary, we already have the values. Now, how can we use it? So to do this, you don't really need to be a really great front-end developer. I mean, it's really simple and fast. So don't need to worry if you've never touched front-end before. Here we have the template. Okay, Right, so for example, we have something here in the details of HTML. The nice thing about Flash is that it uses a template engine called Jinja. So it allows you to basically just plug the values that you already have into the HTML. So it's quite intuitive. So for example, if I query the page and then I get the title word count is equal to 50, then it will render so. So most of the time it's pretty straightforward, you can just display it there. But of course, most things aren't that straightforward as well. So there are, but the good news is there are a lot of things that you can use with Jinja. For example, when we want to display the graph, it's not very visible. Okay. So for example, we already have the graph before. We can actually, surprisingly, we can just use it, load it using image source, which is how you do it with basically every image you would. And we already have created the URL, so we can just plug it in with an additional data. It's basically saying, hey, I have this URL, please treat it as an image and encode it and decode it using base64 because I previously decoded it before. So it will render as an image because we already tell them to treat this like this is an image, not the link or something. So there is all the gory details are actually here if you're curious. So it's here in documentation. Alright, so sometimes we also want to use conditionals. For example, here in this case, if the prediction result is not bounded, I want to display it as in the color of red and not green, for example. Now we can use it. For example, here I have a style CSS. I have the value is not bounded. If not bounded, then it will be red. If bounded, it's going to be green. Now we can just accomplish it with using conditionals, and Jinja has that, thankfully. Yeah. For example, here we know that we use staff value in the CSS. Now the question is, we want to use bounded if the data is bounded is true. Otherwise, we want to use the CSS not bounded, and we can just accomplish this with Jinja. So basically, it just says, hey, let's concate the string bounded to this class if data is bounded, which will return true or false, which is Boolean, as we have said before. Else, we'll just use the CSS class of not bounded. And so it will display a different color for everything. The result is bounded, it's going to be green, and if it's red, it's going to be not bounded. So this is pretty fun. Jinja is able to accomplish all this. Alright, so the last thing is that you may notice, I've said before that you need to keep in mind like the type of your value. For example, we have to keep it as an integer or float because we need to run it through the prediction, right? And of course, we don't want to display that in the web application. So what we need to do is that we want to display something like this with separators and the proper currency or anything else. Definitely not just a string, and definitely not just a float or an integer that is not formatted. Now, Jinja also has something called template filters. So we can define a template filter, which basically means that, hey, when you're displaying this value, I want to change it, I want to format it. It's basically just a function. So it accepts a value, for example, it's a currency, it's a price or an amount of money, for example, 1,000. In integer or string, then we can just format it as usual, and when it's returned, it will be just like this. And we do that by, now there's a little pipe there, so it basically tells us, hey, once you have the data collected amount, I want to display it in another way, and please use the function, the template filter format currency to accomplish that. So I usually just put it in a folder called util/filters if you have a lot of filters. Right. So that's it. And with all of that, you'll be able to accomplish building something like this. But Flask is capable of much more. Actually, there are a lot of extensions available for Flask. There's Flask admin or Flask login if you want. You don't want just anybody to see your web application and so on. And right. So, okay, that's it. Thank you.